Hi everybody, this is Mr. Bowman, and in this video I am going to focus on differential equations, and in a later video I will address slope fields. As far as related rates are concerned, I will post a problem that you can get some practice with that. So let's take a look at this problem on differential equations. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees C at time 0. Important fact there. And the internal temperature of the potato is greater than 27 degrees C for all times t greater than 0. Also an important fact there. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dH dt is equal to negative 1/4 times h, the quantity h minus 27, where h of t is measured in degrees Celsius and h of 0 is equal to 91. Part A. Write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So, to write a tangent line, we need two pieces of information: a point on the curve of the function and the slope of the function at that point. So we already have a point on the curve because we know that at time 0, t is equal to 91, and we need to find h prime of 0 at the slope at time 0. So that's negative 1/4 times h, 91 minus 27, and that is negative 1/4 times 64, which gives us negative 16. So the equation of our line would be y, which represents the temperature of the potato, which they are calling h, minus 91 is equal to negative 16 times x, which they are calling time t, minus 0. If we are going to use that to estimate the temperature at time 3, h of 3 is approximately equal to y of 3, which we're going to solve the equation above for y at t equal 3. We're going to have negative 16 times 3 minus 0 plus 91. And if we simplify that, we get negative 48 plus 91, which gives us 43, and that's in degrees Celsius. So let's take a look at the scoring on that. On that particular problem, we get 1 point for the slope, 1 point for the tangent line, and 1 point for the approximation. So there's 3 points out of our 9 so far. Part B asks us to use the second derivative of h with respect to time to determine whether your answer in Part A is an underestimate or an overestimate of the internal temperature of the potato at time t equal 3. Well, remember, second derivative tells us the concavity of the function. So if the second derivative is negative, the function is concave down. And if we have a tangent line at a point, and we use that to estimate the function value, either to the left or to the right of it, the function value is going to be less than the estimated value. If, on the other hand, the second derivative is positive, and we use a tangent line to estimate the function value is going to be greater than the estimated value. So in Part B, let's go ahead and find the second derivative of h with respect to time. That would simply be the derivative of h prime, or the derivative of dH dt. So what do we have here? We have negative 1/4 times the derivative of h minus 27, which is basically going to be h prime, but we know h prime, so that's negative 1/4 times negative 1/4 times h minus 27, or positive 1/16 times h minus 27. Now, how do you know the sign of that? You got to know the value of h. But the given information says that the internal temperature of the potato is greater than 27 degrees for all time greater than 0. So basically they're telling you that h is always greater than 27. So this is greater than 0 because h is greater than 27. All right, so how do we justify the answer in part A? The answer in A is, well, the second derivative is positive, so this is an underestimate. Because h is concave up for all t. To justify concavity, you have to look at the second derivative, the sign of the second derivative, and you have to justify it on an interval, not at a point. So let's take a look at the scoring. As far as the scoring is concerned, we got the second derivative, and you have to provide an underestimate with a reason. Otherwise, you don't get that 1 point. Which takes us to the last part of the question. We've only accounted for 4 points in this question so far, so the remaining 5 points are in the last part of this question, which is very common for these differential equation problems, and very often you're asked to solve the differential equation, find the constant, and use that to estimate something. So 5 points are riding on this last part. What I would say about that is that even if you can't do the whole problem, do as much as you can to get as many of those 5 points as you can. So let's see what C says. For t less than 10, an alternate model for the internal temperature of the potato at time t is the function g that satisfies the differential equation given there, where g of t is measured in degrees Celsius and g of 0 is equal to 91. Find an expression for g of t, and then based on this model, what is the internal temperature of the potato at time t equal 3? So we have a separable differential equation. dg dt is equal to the opposite of the quantity g minus 27 to the 2/3. Separable differential equation simply means that you can get the g's and the dg's on one side and the t's and the dt's on the other, or whatever the two variables are. So in this case, if you were to multiply both sides by dt, they cancel on the left, and then divide both sides by the opposite of g minus 27 to the 2/3, you end up with dg over the opposite of g minus 27 to the 2/3 is equal to dt. We have successfully separated the variables, which will probably account for one of the points out of the 5, and yes, it does. Now we have to integrate or anti-differentiate both sides. I would probably do a few things to make this easier. I would bring the negative outside. I would bring the g minus 27 up to the numerator and make that negative 2/3 and dg and the integral of dt. So we have the opposite of the antiderivative of g minus 27 to the negative 2/3. You could use u sub at this point and make u equal to g minus 27. I probably wouldn't do that. It doesn't do a whole lot for me. Keep in mind what happens when you anti-differentiate. What happens to the exponent? Your g minus 27 to the negative 2/3. The exponent goes up by 1, so this would be positive 1/3. And then you get a plus c here. But if you were to differentiate this, the 1/3 comes down in front, and you need to cancel that. So I'm going to put a 3 out there. And that is equal to t. So we probably get a point for anti-differentiation as well. Yes, antiderivatives. Next, we need to solve for C, we were told that g of 0 is equal to 91. So negative 3 times 91 minus 27 to the 1/3 power plus C is equal to 0. So C is equal to 3 times 91 minus 27 is 64. So the cube root of 64. And the cube root of 64 is 4. So C is 12. And constant of integration uses initial condition, gets us another point. So we have the following equation that we need to solve for g. Negative 3 times g minus 27 to the 1/3 power plus 12 is equal to t. So let's see. If we were to subtract 12 from both sides, we have negative 3 times g minus 27 to the 1/3 power is equal to t minus 12. Then divide both sides by negative 3. We have g minus 27 to the 1/3 power is equal to t minus 12 over negative 3, which you can do t minus 12 over negative 3. And then cube both sides. So we have g minus 27 is equal to, I'm going to change this to 12 minus t over positive 3 cubed, and then add 27. So g is equal to 12 minus t over 3 quantity cubed plus 27. And that would be equation involving g and t. I don't know if we have to specify that or not. My guess is you'd get full credit for that. The notes don't address that. And then the final thing that we have to do is use that to estimate the internal temperature of the potato at time t equal 3. So g of 3 is equal to 12 minus 3 over 3 cubed plus 27. So 12 minus 3 is 9, over 3 is 3. Cube that, you get 27. Final answer of 54, and that is your final point.